Hello, in this video I'm going to be going over basic naming rules of compounds, and in order to do this we need to have memorized the charges that each atom has based on the periodic table and which column it is in. So for example, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, they're all in the first column, so they all have a +1 charge because they have one outer electron that they can give away. So we have +1, and then the second column, beryllium, magnesium, these guys all have a +2 charge. The transition metals right here, scandium through zinc, they have multiple charges, so those we're not going to worry about for the basic naming rule. But then when you get to boron, this is column 3A, these guys have a 3+ charge. Carbon, silicon, these guys have a +4 or a -4 depending upon their situation. And then nitrogen, phosphorus, they have a -3, oxygen, sulfur, -2, halogens have a -1, and noble gases a 0 charge, and they seldom bond to form molecules. Alright, so doing an example, we have Na and Br. For the basic rule, what we have to do is write down the name of the first element. So Na is sodium. And then we also write down the name of the second element, but we change the ending of it and replace it with IDE. So if we call this one bromine, we change the INE ending to IDE, call it bromide. So we'd have sodium bromide. If we have MgCl2, what we do is write down the name of the first element, magnesium, and if we're not sure what the name of that is, we go to our periodic table, we look for Mg. Just starting out, it might take a little while, but you'll eventually find it, and Mg is called magnesium. And then Cl stands for chlorine, change the ending of the second element to IDE. So it would be magnesium chloride. Now the basic rule, it only works really for column 1 and 2 elements. These two columns, the basic rule will apply. If you have a transition metal, then you have to use the Roman numeral rule, which is different, and we'll get to that. And it always happens between a metal and a nonmetal. And right here is the stair step, this solid line, or stair step. Left of it are metals, and right of it are the nonmetals. And this basic naming applies for ionic compounds where you have a metal in column 1 or 2 bonded with a nonmetal. There are exceptions, and we'll get to those. One is scandium. You're going to use the basic rule, zinc, cadmium, and silver, but we'll talk about those when we talk about Roman numerals and transition metals. Now I want to do some examples where you're given the actual name and you have to write the formula. This is a little trickier, but not too bad once you get the hang of it. So why don't we do an example, let's say calcium oxide. So we have calcium oxide. We're going to write the element symbol for calcium is Ca. That's, oops. Alright, Ca is right here, and oxygen is right there, so that's O. But now we have to double check to make sure that it has an overall 0 charge. Molecules have to have a 0 charge to be balanced. So calcium, it's in column 2, so we memorized it has a 2+ charge. And our oxygen is right over here. Remember, boron's +3, carbon ± 4, nitrogen -3, oxygen -2, halogens -1. So oxygen is a 2- charge. So then 2+ + 2-, put them together and it's overall 0 charge, so we already have it balanced. So trying another problem, let's do potassium sulfide. Alright, potassium sulfide, we have K for potassium, S for sulfide or sulfur. Potassium is in the first column, it's 1 plus. Sulfur is in the same column of oxygen, which is 2 minus. In this case, we do not have charges that equal 0, so we're going to have to basically do a little puzzle to try to figure out, alright, how many pluses equal minus 2, or we could do the crisscross rule. So the crisscross rule says that the charge of the anion will go into the subscript of the cation, and the charge of the cation will go into the subscript of the anion, cation being positively charged ion, anion being negatively charged ion. And we don't put the pluses and minuses in the subscripts. So it's kind of a little trick to help us balance it. So 2 times plus 1 is 2 plus, 1 times 2 minus is 2 minus, and 2 plus 2 minus equals 0. So K2S is balanced, and we really don't have to write a 1 if there's just 1. So we would write this as K2S. No subscript implies that there is just 1. So does the crisscross rule work for every situation? The answer is no. Crisscross rule only works for if you have an odd and an even charge. If you have 2 even charges, it will not work. So an example would be if we had lead 4 oxide, and this is a Roman numeral. That'll make more sense when we talk about the transition metals, but basically the Roman numeral just represents the positive charge of the metal. So that would mean that our lead is a 4 plus, and we have oxygen, and oxygen we have memorized that this whole column is a 2 minus charge. So if we crisscrossed it, you would have 2 here, and the 4 go to the oxygen. 4 times 2 is negative 8, and 2 times positive 4 is plus 8. Plus 8 minus 8 is 0. That should work. However, if you think about it, rewriting this, we have 2 minus and 4 plus. You can ask yourself, how many 2's will fit into 4? The answer is 2 of them. 2 times negative 2 is negative 4. 1 times positive 4 is positive 4. Positive 4 minus 4 equals 0. So your actual answer would be PbO2, not Pb2O4. So recapping it, crisscross rule means that the charges will go into the opposite subscript. So like the potassium charge will go into the subscript of the sulfur, and the sulfur charge into the subscript of the potassium. This works for most situations, about maybe 80 to 85% of the time. You do have some exceptions where the crisscross rule does not work. Both charges are even, it will not work, and you have to do a little math puzzle to try to figure out how many of this charge will fit into this number. And that is the basic rule.